Welcome to my channel Sai Suriyas Academy. If you are new to my channel, then subscribe to my channel and hit the bell icon for more interesting videos. In today's video, we are going to talk about two types of conversions. In the previous video, we had already discussed about the decimal, binary, hexa and octal conversions. If you want to check, then check my previous video. Okay, now today we are going to talk about decimal to binary conversions and then binary to decimal conversions. These two conversions we are going to see today. The first one is decimal to binary, how we can able to change a decimal to binary number as the integer part, and with the fractional part it has different type of conversions. Similarly, in binary to decimal, we are going to discuss about as a integer part how the conversions can be made, and as a fractional part how it can be made. As I had said earlier, the decimal number system consists of base 10 system and it consists of 0 to 9 numbers. But in the binary number system, it consists of only 2 digits, zeros and ones. So when you want to convert to decimal to binary, what we have to do is, when you want to convert an integer number, first we have to divide it by 2 continuously. Continuously divided by 2, and the answer has to be written from the bottom to the top. I will solve it now. Okay. Next, in the fractional part, I will explain the methodologies. Later on, I will explain with the example. In the fractional part, we have to consider before the integer part, we have to divide it by 2. And for the fractional part, what we have to do is, we have to multiply by 2. The number of iterations can be considered, how many times we have to multiply, and then the final integer values are calculated, and then here from top to bottom the answer is calculated. And then next, considering binary to decimal. When binary to decimal, it consists of only zeros and ones. When converting to decimal value, its weightages with the base value is given to each digit from the starting from the position from the right to the left when it is a integer value. That is the whole part without the fractional value. 2 power 0 2, and the values are keep on increasing till the digits it is 2 power 3. Okay, this is for the integer number. Then how come the fractional part we can able to calculate? In fractional part, we have to calculate from the left to right, and the values are, the powers are in the negative values. 2 power minus 1, 2 power minus 2, it keeps on increasing from the left to right side. These are all the methods we are going to see today. Okay, now first we have to solve the decimal to binary, the integer number, that is without fraction value. It is considered as an integer value 353. For this 353 decimal number, we have to calculate it to the binary value. Okay, first we have to divide it by 2, and the remainder values are taken here. Okay, 353 when divided by 2, 1 times, remainder 115, 7 times, again one number remainder 13, which comes 13, 6 2s are 12, and then remainder 1. Since it is divided by 2, its remainder will be either zeros or ones only. We cannot have more than that digit since it is divided by 2. Hope you can understand. Again, divided by 2. Till we reaches zeros and ones, the final quotient and the remainder, we have to keep on dividing. Again, 17. 2 8s are 16. Again, 1 remainder 16. 88, 0. Again dividing by 2, 44, remainder 0. Again 2, 22, remainder 0. Again dividing by 2, 11, remainder 0. Again dividing by 2, 2 5s are 10, remainder 1. Again dividing by 2, 2 2s are 4, remainder 1. We have to calculate till it reaches zeros and ones. So again final step, dividing by 2, the quotient is 1 and the remainder is 0. Okay, we have started from 353, dividing by 2 continuously we reached ones and zeros. Still we cannot able to divide now. So how we can able to write is, starting from this 1 as first digit, we have to keep on writing till the top. So this 353 base 10 is converted into 1 0 1 0 1 1 0 0, again 0 0, again 1. Okay, you can get clear. 1 0 1 1 0 0 1 1 0 0 0 0 1 to the base of 2. Here we have converted the decimal number to binary. Again, this is the whole part, that is the integer part. When considering fractional, how these digits can be converted. Here consider another example, 8.47. This is the integer part, so we have to divide by 2. So dividing by 2, 4, remainder 0, 2, 2, remainder 0, 2 2s are 4, so 2, remainder 0, again 2, 1, 0. We have to start writing from the bottom to the top. So 1 0 0 0, 1 0 0 0. And we have to find the decimal part for the decimal point 0.47. Here for 0.47 we have to multiply by 2. The logic behind is, when we are multiplying by 2, we can consider as number of iterations as 3. We can do any number of times, but just for representing we are going to considering only 3 iterations. 0.47 is multiplied by 2. When multiplied by 2, it gives 0.94. Here the integer part is 0 and the fractional point is 94. So this integer part is represented as 0. Again, only the fractional part 0.94. This has to be again multiplied by 2. That is 0.94 into 2, which gives 1.88. Here the integer part is 1, which is represented integer 1, and this 0.88, again this only the fractional part has to be considered for the next iteration for multiplication. So 0.88 into 2, which gives 1.76. Again the integer part is 1. The integer part is considered. Suppose in case if the iterations may be continued, what we have to do is 0.76 into 2. Again the iterations can be continued. But here we are stopping at 3 iterations. Now these answers can be written as from the top to bottom, which is written as 0, 1, 1. So 1000 here we are returning from the bottom to the top. 1, 0, 0, 0, decimal 0, 1, 1. 0, 1, 1 to the base of 2. So for considering the fractional part, here we are calculating 8 by dividing by 2 and 0.47 we are considering for 3 iterations and calculated, and the integer part here is represented. That's all for the decimal to binary. Decimal to binary as a whole number we had represented, that is an integer number, and then again the fractional part is represented. Now again we are going to talk about the binary to decimal value. Here decimal to binary value is calculated, and then calculating the binary to decimal value on a whole digit, how it can be calculated. When it has a fractional value, how it can be calculated. So binary to decimal 1011. Consider a very small example for your easy understanding. Here we can calculate the weightages from the right side to the left side. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. The weightages keeps on increasing from the right to the left. So again we have to multiply these weightages and then add all those products. So 1 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. Here we had written here 1 into 2 power 3, which is 8. 2 power 3 is 8. So 8 plus 0 into 2 power 2, 0. 1 into 2 power 1, 2. 2 power 1 is 2. So 2. 1 into 2 power 0. Any number to the power of 0 is represented as 1. So 1 into 1, 1. So 8 plus 2 plus 1, which gives the value 11, which is the decimal number. So 11 is of the decimal number. This is the binary to decimal conversions. Again in binary to decimal, when it has a fractional value, how these values can be calculated. For integer part, here we have taken an example number 101,001.0101. This is considered as a integer part. We are going to return the starting from 2 power 0, and the powers are going to increase here till the last digit, that is the MSB of the digit. And here after the decimal point, the powers will keep on increasing, but the negative powers. So here we can return 2 power 0, for 0 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. The values keep on increasing. And here when we are having a fractional part, the values will be increasing or in the negative side with the left to right. So 0 for 0 2 power minus 1, for 1 2 power minus 2, for 0 2 power minus 3, for 1 2 power minus 4. We have to multiply all those weightages and then finally we have to sum the values of the products. So 1 into 2 power 5, 0 into 2 power 4, 1 into 2 power 3, 0 into 2 power 2, 0 into 2 power 1 plus 1 into 2 power 0. That till this the integer values are represented here. Just for your understanding I am marking this. And then again for 0 into 2 power minus 1, 1 into 2 power minus 2, 0 into 2 power minus 3 plus 1 into 2 power minus 4. The values keep on increasing. That is the negative values in the from the left to right hand side. 1 into 2 power 5 which gives the 32. 2 power 5 the value is 32. This is 0. 0 into 2 power 4 and 1 into 2 power 3. 2 power 3 value is 8. So 8 is represented. Again 0. Again one more 0. 0 into 2 power 1 and then 1 into 2 power 0, that is 1 into 1 which gives 1. Again 0 into 2 power minus 1, 0 and then 1 into 2 power minus 2 which is the value. How we can be able to calculate is 1 into 1 by 4, that is 1 by 4 value. 1 by 4 value when converted into decimal value, that is when we divide 1 by 4 which yields the 0.25. 0.25 value you will be getting. And then again 0 into 2 power minus 3, 0. And then plus 1 into 2 power minus 1. How you can be able to calculate is 1 into 1 by 2 power 4 is 16. 2 power 3, 8. So 2 power 4, 16. Since we are having negative values, the 16 is written in the downwards, 1 by 16. So 1 into 1 by 16. So which gives 0.0625. And both the whole digit values will be added here, that is the integer parts, and the decimal values will be added. When adding 0.25 and 0.0625, we will be getting 0.3125. So 32 plus 8 which gives 40, 40 plus 1 which gives 41, 41.3125, adding the decimal values. So this is the final decimal value. I hope you can understand. Once again I am consolidating all those points. Today we had discussed about decimal to binary as an integer number, as a fractional number, and then binary to decimal as a integer number, binary to decimal with the fractional number. When we considering decimal to binary, the whole integer number is continuously divided by 2 till it reaches ones and zeros. It has to be continuously divided and the answer will be evaluated from the bottom to the top. Starting from 1 and then here writing all those numbers 0, 0, 0, 0, 1. This is the final binary value. And then when considering fractional point 8.47, again the 8 is considered as a whole number, so 8 is continuously divided by 2 till it reaches ones and zeros. So again from bottom to top, this is written as 1000,000. Dot. This 0.47 is how it can be evaluated is, here we are considering 3 iterations and 0.47 is multiplied by 2. The whole number integer part is taken here and again the fractional value is multiplied by 2. Only the integer values are, we are segregating the values. Again 1.88, integer value 1, again it is multiplied 0.88 into and the integer value 1. 1000 dot 011 we had attained the binary value. And then for binary to decimal we are adding weightages. For the whole number we are adding from 2 power 0 to 2 power 3. Similarly here for the integer part, it is having a fractional for integer part. In this portion, the integer portion 2 power 0 to 2 power 5 we are adding, and for the fractional values we are adding from 2 power minus 1 to, it keeps on increasing from the left to right, 2 power minus 1 to 2 power minus 4. We are multiplying with the particular digits, the positions, and then finally we are summing all those numbers and we get the result 41.3125 to the base of 10. And then finally a small work for you. Find the value of 93.86 to the base of 10 and convert it into decimal. And then find 11001.1010 to the base of 2 and convert it to decimal. Find the answer and write it in the comment section. Okay, that's all for today's video. We'll meet you in next video. Keep supporting Sai Suriyas Academy. Thank you.